Hello and welcome to this new episode of OTT Talks. My name is Enrique Mendizabal and I'm here with Marcela Morales, who's an associate at OTT. Marcela and I are going to talk about a study that she authored on scientific advisory systems. Hi, Marcela.
Hi, Enrique. Nice talking to you today.
So thank you for joining me. This project began a few months before the pandemic hit, so over 2 years ago. We were asked by the Peruvian government and the British Council in Peru to look into scientific advisory system models and to develop a scientific advisory model for Peru. We worked in partnership with Universidad del Pacífico, with Pablo Lavado there. But before developing the model, we asked Marcela to undertake a review of experiences from around the world. And the paper we published is based on that. Marcela, can we start with kind of a brief overview of the paper? Can you tell us a little bit about which experiences you studied? What issues did you cover in the paper?
Yeah, for sure. So looking back, it was a very interesting timing. We did the study. This was before the pandemic. So when we were looking at the systems, we were just looking at what had been done. And a few months in, the pandemic started. So the study got a new meaning suddenly. So it was very interesting to see how the systems that we were studying had to adapt to the pandemic. So the study initially looked at 6 countries, the advisory systems in 6 countries. We looked at 3 countries in Europe, the UK, Germany, and Spain, 1 country in North America, Canada, and 2 countries in Latin America. We looked at Chile and Brazil. So the main purpose of this diversity was to get a sense of different structures, existing structures. So, and I think it's important to note that it was never the intention to see which system was better. The exercise was more focused on identifying lessons, what has worked in specific contexts, and then for us to have some input to make recommendation, what has worked and why. And overall, we were focusing on scientific advisory system where governments were the main users of this knowledge. And I think it's a very interesting and important differentiation because advisory systems take different forms. And so the receivers and the producers of knowledge, of scientific knowledge, can be different actors. So in this particular case, we were focusing on governments, and we were trying to understand which structures were allowing governments to generate and use scientific evidence.
Yeah, and one of the first things that I remember sort of latching on to when you presented your findings was this concept of policy for science versus science for policy. The government body that we were working with, the National Science Council, is a body that is focused on policy for science, right? So they're thinking about the public policies that are necessary to promote scientific production, innovation, so technological development, if you want. But when we look at scientific advisory systems, what we're talking about is science for policy. As you say, the consumer, the owner of the system to some extent are not the scientists, but the policymaker, the politicians, right? The whole system has to be useful to politicians so that politicians will want to keep it around and want to strengthen it. So that was one of the first, I think, lessons, and very important lessons in that review that you conducted. But can you tell me a little bit more about maybe the similarities or differences that you found in your review of these different systems?
Yeah, for sure. I think one of the key differences is related to what you just said, Kike, which is so the main purpose of the systems. We had this policy for science function and the science for policy function. So just to clarify, policy for science is the government providing guidelines to the production of scientific knowledge at the policymaking level. And the science for policy function is the use of scientific evidence to inform policy making and decision making. So one of the key differences we saw is that, so I'm going to use the example of Latin America. The two countries we looked at, for example, the main function of those of the ministries of science, for example, was policy for science. And in the UK, in Canada, even in Spain, we saw this other model that was more prevalent, which is like science for policy. So we saw these structures being more developed in Europe than in Latin America. And I think that was also more visible during the pandemic. So when the pandemic hit, countries that already had a strong science for policy function were more able to just jump and use these structures to respond to the crisis. While in Latin America, countries had to develop and create these bodies when the pandemic hit, and that brought an additional set of challenges that we can discuss as well.
Yeah, exactly. I think that's an interesting interim point as well. So in Latin America, we have the policy for science area developed. In Europe, we have that developed, but we also have the science for policy. And those two functions are connected, but not necessarily governed in the same way, right? Or run in the same way.
Yeah, for sure.
Can you tell me a little bit about how these systems reacted during COVID? I know this wasn't what you were going to look at in detail, but this was in the middle of the project. So are there any lessons about how the systems responded to COVID?
Yeah, I think one of the most interesting things that we saw was that almost every country in the world was unprepared from the pandemic, independently of how old or how well established their advisory systems were. It was a shock to their systems. And in the few months, we saw differences that were related to certain characteristics of their advisory systems that allowed them to respond in different ways to the crisis. So, for example, as I was mentioning in Latin America, many countries had to create advisory systems on the spot to be able to respond to the crisis. So, for example, in Chile, a crisis advisory group was created on the spot. I think it was during February and March 2020. So the pandemic was already happening. So they actually had to put together this group, bring experts together. And the challenges they faced was that included, for example, that people weren't sure who to include. There were issues around transparency, about efficiency, and how the advice was being provided. So they had to deal with these issues. In Germany, for example, because there was an enabling environment that has been running for a longer time, and there is a stronger system of that allows for scientific advisory to be delivered to the government, in general, the country was able to respond to the crisis in a faster, more efficient way. So they kind of relied on these existing structures, and they just put everything to work at the same time. So I think that is a very interesting difference between both. And I guess the other lesson that came out from the pandemic and advisory systems is that the crisis kind of showed the weaknesses of knowledge systems overall, which included, for me, I find very interesting that it also highlighted the overall sentiment towards science. And then you could see countries where the trust towards science and scientific evidence was stronger. It was also easier for governments to deliver plans that relied on scientific evidence, while in countries that were struggling with that, had weaker scientific systems and trust systems towards science, it was more difficult and it presented more challenges.
Which is important, which draws to the importance that you make in the report, which is to make these systems or the bodies in the system, whether it's an advisory council or a series of advisors, public, right, well known, transparent, accountable to the public to some degree, because you want them to be trusted not just by the politicians, but you want the public to trust them as well, right? The public needs to trust that the scientific advisory system and the individuals involved in it are providing the best scientific advice possible, and this means that they have to be transparent. What other lessons could you identify from your study? Lessons that other countries that want to develop these systems, or countries that want to reform their systems, might want to take into consideration.
I guess one of the key lessons is about balance. So scientific advisory systems are all about balance between formality and flexibility, between distance and closeness to the government, between being neutral and very clear with scientific advice. And I think one of the key characteristics here overall is flexibility. So all the systems need to find a balance between being flexible to adapt to upcoming threats and circumstances, but also have this degree of formality that allows them to go back to established structures that kind of, let me go back to the example of Germany. When the crisis hit, they didn't have to create a system from scratch because these structures already existed, but they did create, they had the flexibility to create a very specific pandemic response for this particular crisis. So we had this balance in this particular, in the case of Germany, for example. But for example, also going back to trust, I think it's a very delicate balance between the public trusting the neutrality of the scientific advisory system and also the government knowing that the advisor or the advisory system is aware of the political implications that every scientific advisory has. Because we must be aware that even though a scientific advisory system's main function is to provide scientific evidence, this happens within a framework, a political scenario. So it's not neutral at all. And this is also a very delicate line to walk in, I think. So the countries that managed to do well did it kind of like walk these very specific lines and did it successfully.
And something else that I found very useful or very interesting is that the system in a way has to reflect the context, right? You can't impose a system everywhere, right? The system has to be reflective of what's going on in the context. And when we took your study to the Peruvian case, so that we could come up with a feasible option or a feasible recommendation, what we ended up doing was asking politicians and policymakers how they preferred to access scientific advice. And as you say, it was interesting that this tension that you talk about between the closeness of the scientists to them and to their interests or to the research community came up really, really clearly, right? Politicians and policymakers wanted scientific advice, but they also wanted scientific advice that understood the situation they were in, right? That understood the challenges they were facing, which makes me think then that the scientific advisor needs to be this sort of very unique type of individual, a scientist or someone with a scientific background, but also a politician or a political or a policy entrepreneur or someone with a political background or sufficient political understanding. Is there anything in the study, in the models that you looked at, that says something about the roles of the individuals who make up this space?
Yeah. Yes, I mean, what we found, as you mentioned, Kike, there's this figure that is widely used in several models, which is the chief scientific advisor, which is a person that is appointed usually by the government to provide direct advisory to the president of the prime minister. And this figure usually is also in charge of coordinating the efforts of scientific advisory in other departments of the government. But as you say, it's a very tricky position to some extent because it has to be someone who is a scientist, so who is comfortable working with the evidence, but is also someone who is aware of the political realities. So what we found in the evidence of successful, I mean, I have to say it's important to point out that this position is not exempt from controversy. So it has to be someone who is comfortable with controversy and also in a political environment. It cannot be someone who is just a scientist or someone who is in the academia. It has to be someone who has to be able to move between these two spaces. So some of the things we found as important characteristics for this figure is, again, flexibility to work with different actors, the ability to communicate not only to policymakers, because it's important to understand that this figure is not only accountable to the government, but also to the public. So it's also someone who can communicate scientific evidence to different audiences. So it has to work with fellow academics, fellow scientists, but also be able to communicate with the public. And I think that's it's a key characteristic, and it's something that usually we don't see a lot in many contexts. Usually when we work with policymakers, we see that scientific advice is tailored to them. And then when it's only the academia, it's tailored to other academics and scientists. And it's rarely like the regular citizens are rarely included in this process. And we found that this is also an important role for the scientific advisor, which is be able to bring together these three spheres. So yes, public policy, yes, the academia, but also civil society, and the people who are going to be in the long term are going to be the recipients of whichever decision the government makes.
Great. This seems like one of those jobs that Simon Maxwell refers to, one of the best jobs in the world, but also one that is impossible to do perfectly.
Definitely, yeah.
But we need more of these roles. So, and I guess the challenge is to find ways to train, to prepare, to sort of develop the next cadre of scientific advisors that can fill in those roles, not just at the top of government, but also, as you mentioned, in different sectors, even in parliament, and in subnational levels. Anyway, that was very, very interesting. Thank you, Marcela, for joining me in this episode of the OTT Talks. And of course, I invite everybody to read the paper and let us know what you think. Thank you.
Thank you, Kike.